that is wind blows from an area of high pressure to low pressure area. And if the distance between the high pressure and low pressure area is very small, the wind gushes very quickly. That means the pressure gradient is very high. For a very small distance, the pressure is becoming less and less. So that anything to do with gradient means we are changing something with respect to distance. That is why if we measure the distance between isobars, if isobars are very close by, that means the pressure is changing over a very short period of time, of a very short distance. Within a matter of 4 hours, if the pressure drops 2 millibars, you're going to have very strong wind suddenly, because the pressure gradient is large. If the same 2 millibars is changed over a period of 15 hours, that means the distance between the isobars will be much more. So we say the pressure gradient is less. That's why we are getting lesser force winds. Are you with me?
Yes, sir.
No, be very clear on that. You want me to want to ask 10 times, I will explain both the gangway thing and the pressure gradient, because that plays a very important element. We encounter the wind on the two elements. One is the speed of wind, yeah, wind force 3ak, wind force 6, and that is the resultant of the pressure gradient force. And the wind is steady or it is changing direction, that is as a result of the Coriolis force. I'm coming to that, but we need to understand the pressure gradient force. Before we understand the pressure gradient, we need to understand pressure gradient force. Before understanding the pressure gradient force, we need to understand the pressure gradient. Before we understand pressure gradient, we need to understand what is a gradient. So first tell me, have you understood gradient?
Yes, sir. Yes.
Let me put it this way. Let me write it here. Gradient means change of something with respect to distance. This something can be anything. It can be angle, it can be change of height, can be anything. Are you with me? Gradient, have you understood? Because you cannot talk
Yes,
about
sir.
Yes.
you
Yes, sir.
cannot talk about gradient in the absence of distance. यहाँ पे what is this something? When we are talking about, let's see if I can insert a ship. Maybe this ship. Okay, that is good enough. In this case above, we are talking about what? Angle. Change of angle with respect to the distance. Don't bite that. I'll ये तो यार auto save होता है because the slide is very huge. Okay, so we are talking about above change of this angle with respect to distance. Now, if we want to change the gradient, that means we are the only way that we can change the angle, make it less by increasing the distance. So what we are doing is we have changed the gradient of the gangway for a comfortable climbing. Similarly, change pressure with respect is called pressure gradient. Are you with me?
Yes, sir.
Yes, sir.
Therefore, change pressure, इससे पहले एक और लॉ लगाना होगा. Distance, sorry, element change inversely proportional to distance. Element change यहाँ पे क्या था? We have changed the angle, made it less, which can only be possible with an increase in distance. That is what is inversely proportional, right? One thing increases, the other thing reduces. Are you with me till here?
Yes, sir. Yes.
Yes, sir.
Similarly, therefore, change of pressure over shorter distance will have higher or lower pressure gradient. Distance is less.
Hi, sir.
Excellent, because it is inversely proportional. मैंने वही कहा ना, तुम लोग को मेरी जरूरत ही नहीं. You guys are so good. Will have higher pressure. Are you with me till here?
Yes, sir.
Thus, higher pressure gradient force. If there is a higher pressure gradient force, wind will be stronger or less strong.
Stronger.
Now you
Stronger.
understand. Very good. Now you understand the meaning, importance of the spacing of the isobars. We will be doing in the pressure systems and etc. The 7 types of pressure system. I'll be doing that as a recap also. So, the two forces which act on air. Air is stationary, which create the wind that we experience out at sea. One is the speed, the force of the wind, pressure gradient force. The difference between the high pressure and low pressure over how much of distance between the high and low pressure will decide whether we are getting what kind of wind. Wind force 3 or wind force 6. Coriolis force decides the changing wind direction. When nahi to Wind will always be coming from a single direction, high pressure to low pressure. Why should there be a change in direction? That is where the importance of the Coriolis force comes. Now, this figure that you see is a very imaginative figure where the earth is not rotating on its axis. It is just there. ऐसे होता तो यहाँ तो we would have had all day or all night depending upon the angle of, I mean, depending on the latitude and what month we are. We don't get into that. This is your polar region. It is always cold. Yes?
Yes, sir.
Yes, air in contact with the surface of the earth at the poles will be cold.
Yes, sir.
Yes, sir.
That means it is dense. We are talking about a permanent high pressure here. That is point number one. Let's take this equator, which in comparison is always hot. Air in contact with the surface around the equator will be hot. It will expand. It is continuously rising, meaning as compared to here, there will always be a low pressure area.
Yes, sir.
तो अगर अर्थ सर्कुलेट नहीं कर रही होती तो भैया जनरल डायरेक्शन ऑफ द विंड in northern hemisphere would be from south pole to equator, sorry, north pole to equator. Here it will be from south pole to equator. आप कर लो जो कुछ करना है, वो तो डायरेक्शन एक ही होना है, because there is nothing to disturb the direction. The only resultant wind will be as a result of the pressure gradient force. But in reality तो ऐसा नहीं होता. Wind changes direction. Yes or no?
Yes, sir.
Now imagine this, that this earth is rotating from west to east. You are standing here at this arrow. You are stationary. You on the earth have moved. The wind coming from here to here, will it say it is coming directly from north to south? Will you feel that, or you will feel that the wind is coming from somewhere else? Because you have moved. Will it, if you are here on the equator, will you always feel wind is always a northerly wind because it is blowing from high pressure pole to the low pressure on the equator? The wind direction, aankh band karke, it will always be northerly winds. That is if the earth is not rotating. But if the earth rotates, you are here, you are moved, will you still be feeling the wind coming from northerly direction? लगेगा कि wind तो कहीं और से आ रही है.
Yes, sir.
Yes, sir. Yes, sir.
That imaginary force which makes the wind direction change is what is the Coriolis force. एक और example लो, that we can imagine. You are on that merry-go-round in the Jhula Ghar in the park. I am sitting on a bench stationary. You are on the merry-go-round stationary. You throw a stone at me. It will take that parabolic path. It will land on my head. You are not moving. I am not moving. Correct? You are here with me?
Yes, sir.
Now,
Yes, sir.
let's start moving circularly. उसको धक्का देते हैं. Now you are moving circularly. आपने aim किया. You are moving in a round. You throw the stone at me. Actually, the stone is taking its parabolic path, but because before the stone reaches my head, you have changed your direction, so you will appear, it will appear to you कि यार मैंने तो stone सीधा फेंका था, but now the stone is having a rightward parabolic path because you have rotated toward the left. Yes or no? Are you with me? Are you with me?
Yes, sir. Yes.
So that imaginary force which you feel because of your own rotationary movement, which gives an impression that there is some imaginary force which has pushed the parabolic path of the stone toward the right, that imaginary force is the Coriolis force. It is exactly like the M meta center which we use in stability. M is an imaginary point, whereas G of the ship is a fixed visible point. If you have the instrument, you have done precise calculation. This is the G, so much distance from here or there, from the keel, etc. You can actually paint on the ship tank or whatever, tank top. This is the G of the ship at the moment. But M you can't paint, it is an imaginary point, but at the same time, that is the reference point we take for calculating the GM. Similarly, imagine Coriolis force like M. It is an imaginary force which is only felt. Felt how? Changing direction of the wind. It is only felt because the earth is rotating continuously from west to east. That force is the Coriolis force. And when we are talking about trillions and trillions of mass or volume of air above the surface of Earth, that gives us the experience on the surface. The wind is changing the direction. It is because of the rotation of the Earth. Now I have a question. Where you will find the effect of Coriolis force the maximum, on the poles or on the equator?
Equator.
On the equator.
No. यार यहाँ पे तो यार the circumference is only this much. यार यहाँ it will be poles पे तो you can actually see the sun rise and set within a matter of 2 hours. Yeah, that is the effect of the earth.
पोल्स पे सर वो मूवमेंट ऐसे सर्कुलेशन रोटेशन ज्यादा होगी ना,
मैक्सिमम एहसास होगा ना, मैक्सिमम एहसास तो
नहीं,
आपका पोल पे ही होगा. So the effect of Coriolis force is maximum at the pole. That means at the pole the wind direction changes every half an hour. As you keep coming south towards the equator, you are feeling the effect less and less, and therefore right at the equator, the effect of Coriolis force is zero. That means the wind that you will feel dot at the equator will be only resultant of your pressure gradient force. हाई प्रेशर वहां पे है, लो प्रेशर यहाँ पे है, तो विंड वहां से यहाँ आएगी. अगर विंड हाई प्रेशर वहां पे है, लो प्रेशर यहाँ पे, तो विंड का डायरेक्शन यही होगा. कोरियोलिस फोर्स का कोई इफेक्ट नहीं होता है. एंड as we will be doing when we are doing Doldrums, ITCZ, etc. tomorrow morning. That's why it is said that effect of Coriolis force starts feeling around 3 to 4 degrees north or south latitude, because that is the lowest latitude where you can start feeling the frequency in the change of the wind direction, because Coriolis force has now started acting. So the wind that we experience out at sea is a resultant of two forces: pressure gradient force deciding the wind speed, Coriolis force the wind direction. Higher you go on the latitude, you will always find that the wind changes direction more frequently. इस वॉच में यहाँ था, अगली वॉच में वो वहां से आता है, because the effect of Coriolis force has started playing. You go reach the pole, every 10 minutes there will be a change of wind direction. Gradient is an element changing with respect to distance. Here, that is a gradient. So pressure gradient is the change in atmospheric pressure with respect to distance. So here, these are the isobars. The circles are the isobars. This is 1022. This is 1018. That means the pressure is reducing, but over a larger distance. So the pressure gradient is lesser. Therefore, the pressure gradient force will be less. The wind force, the speed of wind will be less. If we take these closely spaced isobars, between this and this distance from 1013 to 1018, 12 millibars has reduced in a very small distance. That means the pressure gradient is very large. The pressure gradient force will be very large. We are going to have wind force 6 to 7 as a minimum. Change of an element, that is pressure, with respect to distance, and the association with respect to distance is always inversely proportional. If the element change happens over a shorter distance, that means change is big, distance is short, gradient is more. If the change is over a larger distance, that means the change is small, distance is large, the gradient is less. Here, the change is of pressure, so we talk about the pressure gradient and the resultant pressure gradient force. Are you with me?
Yes, sir.
Yes, sir.
Now, why this is important? Because there are permanent different atmospheric pressure belts north and south of the equator. Low pressure, high pressure, low pressure, high pressure, which when coupled with the Coriolis force has different direction winds. So for that, to understand this, let's see this video about the atmospheric circulation and how the different pressure belts are created. What I'm trying to say is, I will just show you this diagram first, which will be coming after the video. High pressure, this is low pressure, high pressure, low pressure, high pressure. How these permanent pressure belts are formed? For this, let's have a reference to this video.
Wind patterns that have developed on planet Earth. While understanding the basic concepts behind the development of pressure belts, we will not take into consideration the tilt of the axis and the influence of land-water distribution. The equator divides the globe into southern hemisphere and northern hemisphere, and equatorial belt extend up to 5 degree north and 5 degree south. Equatorial region receives nearly vertical rays of the sun, and this heats up the air near the equator. When temperature increases, pressure decreases. So, along the equator we have low pressure, and we call this region as equatorial low pressure belt. The warm air starts rising up in the troposphere, and as the warm air is rising, the temperature drops. After rising up to a certain point, it stops rising upwards because it becomes cooler and it is obstructed by tropopause. So the air spreads out. The air starts moving in the southern and northern direction. As the air is moving, it becomes denser, and after a certain point, it sinks down to the surface. So at around 30 degrees north and south, we have sinking air. This sinking air is cool air, so it forms high pressure systems. These regions are called as subtropical high pressure belts because these regions lie outside the tropical region and at the same time adjoining the tropical region, the sinking air now moves towards north and south. So, along the equator, the warm air rises, spreads out, and cools and sinks down. In this way, it develops convectional currents. At the poles, the sun rays are very much inclined. So we have cold air that sinks. These regions are known as polar highs. In the northern hemisphere, the air moves towards the south, and in the southern hemisphere, the air moves towards north. At this point, we have air coming from north and south. So, at this point, the air converges and rises up. These regions are known as subpolar lows. So, at 60-degree latitudes, we have low pressure system because we have rising air. Along the equator, the air is rising because of convection, and at subpolar lows, we have rising air because of convergence. This rising air also spreads out, cools and sinks. Same things happen in the southern hemisphere. On the surface of the earth, along the equator, the winds move from high pressure regions to low pressure regions. That is from subtropical highs to the equatorial low in the northern and southern hemisphere. These winds bend to the right in the northern hemisphere, and in the southern hemisphere, the winds bend to the left. And this is described as Coriolis effect. The winds bend to the right and left in the northern and southern hemisphere respectively, because the earth is spherical in shape and the earth rotates from west to east. In the wind bends towards right and left in the northern and southern hemispheres respectively. Even at the polar region, the same phenomena can be seen.
We are discussing the different types of winds, doldrums. Then we'll come to intertropical convergence zone, the hot latitudes, westerlies, polar easterlies, etc., etc., etc. All part of your short notes. But now our focus is what are the permanent pressure belts which continue throughout the year. That will create the general direction of wind, plus what may be some local condition which may or may not influence. So we have the low pressure belt here. We saw the reason. We have a subtropical high pressure belt. So this is high pressure, low pressure. It is supposed to move from here to here. But next we are going to take another video, 2 videos of the Coriolis effect, which deflects the wind towards the right in the northern hemisphere and towards the left in the southern hemisphere. So high pressure to low pressure, it is supposed to flow directly, but because of the Coriolis effect, it gets deflected towards the right. So you have northeasterly winds permanently between, you can say 0 to 30 degrees, which are called the trade winds. I'll come to the trade wind. Are you with me till here? Why these are the northeasterly direction?
सर अभी जो वीडियो बताया था ना उसमें सर उन्होंने कहा था कि जो 0 डिग्री है अपना इक्वेटोरियल बेल्ट, वहाँ पे सन की रेस डायरेक्टली मतलब पड़ती हैं, तो इस वजह से गर्मी होती है, तो वहाँ पे लो प्रेशर बेल्ट बन गया।
belt is 0 to 5 north and 0 to 5 south. Next.
Yes, 5 degrees north to south. ऐसे ही
Correct.
सर जो बेल्ट है ना सर, ये सब ट्रॉपिकल और ये सब पोलर और हाई प्रेशर बेल्ट, ये सब कैसे कैसे बन रहे हैं, इनका क्या मतलब कारण क्या है?
अच्छा, ओके, इनका कारण ये है, आई विल शो द वीडियो अगेन. दिस इज अ 2-dimensional थिंग, वहां पे और एक्सप्लेन किया था. नाउ this, because of low pressure, that means this area is heated up, air has become warm, it is rising, correct? That's what is creating a low pressure bed. Now when the air is rising, it is cooling down adiabatically, of course, because the pressure is less, expansion, the pressure is less, it is getting a chance to cool down, expansion, cooling. But that happens till a certain height above the surface of the earth. वहां पे वो पूरी तरह कूल हो जाती है. प्लस दिस इज ट्रोपोस्फियर, द फर्स्ट लेयर ऑफ द एटमोस्फियर, दैट इज separated from the layer above by a band called tropopause, which prevents the air from continue to rise. वो वहां पे obstruct होती है, तो it moves, it gets distributed like this and like this. At this height, which could be 5 kilometers above the earth, the air is very cold. Because it is cold, it has become heavy, it starts sinking. And when it is sinking, the cold air, at this latitude, the temperature in comparison is also cold. So sinking low air with lesser temperature creates a high pressure area. I will show the video, but keep this in mind. Are you with me till here?
यस सर. सर जो ये विंड है, मतलब जो ऊपर जा रही है, अपन ने जो कल पढ़ा था ना, मतलब फिनोमेना, व्हेन द राइजिंग एयर ऊपर जा रही है SALR और DLR के हिसाब से, तो सर वो जाके सर मतलब वहाँ पे क्लाउड फॉर्मेशन हो रहा है. तो यानी कि सर मतलब कुछ ज्यादा ही मतलब ऊपर जा रही है कि ये टॉपिक तक मतलब 30 डिग्री तक मतलब चली गई ऊपर.
The tropopause is at a height of about, on an average, you can say 8 kilometers above the surface of the earth. वो cloud formation will happen, but the remainder of the air will continue to rise up to a maximum on an average of 8 kilometers, because it gets obstructed by a layer of atmosphere that is called tropopause. वो उससे ज्यादा उसको ऊपर उठने नहीं देता. अब जब ये ऑब्स्ट्रक्शन यहाँ पे आ गया, तो भाई इतना फोर्स तो है नहीं एयर में कि वो इट गेट्स डिफ्लेक्टेड बैक टू द अर्थ. तो वो क्या होता है, दैट गेट्स डिवाइडेड फ्रॉम हियर, आगे नहीं उठ सकता है, तो इट गेट्स डिफ्लेक्टेड टुवर्ड द नॉर्थ पार्ट ऑफ इट, एंड पार्ट ऑफ इट गेट्स डिफ्लेक्टेड टुवर्ड द साउथ. Now this is all happening around on an average of 8 kilometers. 8 kilometers पे the air is very very cold, it is dense, it is heavy, so obviously it will start sinking down. When it is sinking down, the very cold air, plus at 30-35 degrees latitude, the temperature is definitely lesser than here. So sinking cold air coupled with very cold temperature creates a permanent high pressure here as compared to this.
In this video, we shall learn about the various pressure belts and wind patterns that have developed on planet Earth. While understanding the basic concepts behind the development of pressure belts, we will not take into consideration the tilt of the axis and the influence of land-water distribution. Equator divides the globe into southern hemisphere and northern hemisphere, and equatorial belt extend up to 5 degree north and 5 degree south. Equatorial region receives nearly vertical rays of the sun, and this heats up the air near the equator. When temperature increases, pressure decreases. So, along the equator we have low pressure, and we call this region as equatorial low pressure belt. The warm air starts rising up in the troposphere, and as the warm air is rising, the temperature drops. After rising up to a certain point, it stops rising upwards because it becomes cooler and it is obstructed by tropopause. So the air spreads out. The air starts moving in the southern and northern direction. As the air is moving, it becomes denser, and after a certain point, it sinks down to the surface. So, at around 30° north and south, we have sinking air. This sinking air is cool air, so it forms high pressure systems. These regions are called as subtropical high pressure belts.
We are clear about the equatorial low pressure belt, and we have understood how the subtropical high pressure belt has been created. It's all a relative factor. As compared to this low pressure, the pressure is higher here, so therefore the wind will always be flowing from the 30° north towards the equator, the northerly wind coming straight. Are you with me till here?
Yes, sir.
Yes, sir.
ये deflection वाला part, I will come back to it again after I have showed you and discussed the Coriolis effect. Up till now, we will take from this high pressure, there is a permanent wind flow toward the equator from north to 0, and in the southern hemisphere from south to 0. Now, we need to understand how low pressure is created here and how high pressure is created here. For that, we will continue on the video.
Because these regions lie outside the tropical region and at the same time adjoining the tropical region, the sinking air now moves towards north and south. So, along the equator, the warm air rises, spreads out, and cools and sinks down. In this way, it develops convectional currents. At the poles, the sun rays are very much inclined. So we have cold air that sinks. These regions are known as polar highs. In the northern hemisphere, the air moves towards the south, and in the southern hemisphere, the air moves towards north. At this point, we have air coming from north and south. So, at this point, the air converges and rises up. These regions are known as subpolar lows. So, at 60° latitudes, we have low pressure system because we have rising air. Along the equator, the air is rising because of convection, and at subpolar lows, we have rising air because of convergence. This rising air also spreads out, cools, and sinks. Same things happen in the southern hemisphere. On the surface of the earth, along the equator, the winds move from high pressure regions to low pressure regions. That is from subtropical highs to the equatorial low in the northern and southern hemisphere. These winds bend to the right in the northern hemisphere, and in the southern hemisphere, the winds bend to the left. And this is described as Coriolis effect. The winds bend to the right and left in the northern and southern hemisphere respectively, because the earth is spherical in shape and the earth rotates from west to east. In the same way, in between 30 and 60° north and south, the wind bends towards right and left in the northern and southern hemispheres respectively. Even at the polar region, the same phenomena can be seen.
Gentlemen, are you with me? Now I need to explain.
Yes, sir.
We have understood the movement of wind. Forget about deflection at the moment. Let's take it straight. High to low pressure, high to low pressure. How the high pressure was created here, wind is moving from here to here. Now, let's come to the poles, North Pole and South Pole. It is a very cold region. Air is very cold, very dense. So there is a permanent high pressure area here. What happens is when the air is moving from high pressure, this is because of the convection. I need to show you this part, that how this subpolar low, because what happens is that from the pole, the wind is coming here, from 60 degrees, it is coming here, it rises. It is converging and rising. It is converging and rising, which is creating that low pressure area at 60 degrees north because of convergence. The air which is moving from here to here and here to here, after converging and meeting, it is continuously rising. So there is a permanent low pressure here, which we call as the subpolar low. High pressure to
So
low pressure. Go ahead.
Since the air is rising, it will be a low pressure over there.
Or bilkul, which is rising at this point. Why? Because if you see, air has started moving from high pressure, and from the horse latitude that is 35, it is coming here. At around this area, they converge. That is around 60 degrees north. The moment they meet and rise, it creates a permanent low pressure area here. So that there is a difference between creation of low pressure at 60 north and equator. Equator is only because the air has got heated up because of sun's rays, it is rising. Here, because two different parcels of air are meeting, instead of like locking horns like two bakris, they meet and rise up. Rising air will create a low pressure area here. So in relation to this, this is a high pressure. From here, it will go here. From high pressure, it will go here. So this is a permanent wind flow direction throughout the earth between the various pressure belts at different latitudes. At the moment, keep in mind, it is straight flow, high pressure to low pressure straight, high pressure to low pressure straight, high pressure to low pressure straight. The deflection, I'm coming to it, but have you understood the formation of this different pressure belt? Because this is what is asked, and how the winds are created. Full mark you'll get once you've understood it.
To show an effect that will have you doubting your very own eyes. Now, they don't know it yet, but our budding ball players sitting on our specially rigged merry-go-round are about to demonstrate a rather astonishing optical illusion.
Right, here's the game, right? You're going to throw the ball straight. So what's your name? Victor, right? Yeah. But this time, I'm going to complicate things slightly. I'm going to rotate the merry-go-round counterclockwise. So you throw it whilst it's moving. What's going to happen?
I don't know why, but I feel like if we're going fast enough,
yeah,
like I might actually be the one catching the ball.
Okay, so you're going to throw it and you're going to catch it. All right.
Yeah.
Right, what's going to happen, dude?
It's going to veer off to the left.
So the ball is going to swerve off to the left.
Yep.
And you might catch it.
Possibly.
Okay, good. Right, so what's going to happen?
I think it's just going to come straight to me, and I'm going to catch it like the champion that I am.
Show me the catch. Okay, great. Right, okay, so everyone, no, hang on, one more. Spencer.
He's not arrogant.
Just quietly
He's
confident.
not catching it. He's
Really?
not catching it, no.
So what's going to happen to the ball?
I'm catching it. It's right here.
Great, so we've got one saying to go off to you, one saying come to you, Spencer, and you think it goes straight ahead, but you think you'll be the one catching it.
Yeah.
Now remember, the ball will be thrown straight across the spinning merry-go-round, but where will it end up? Will it be caught by the thrower, Will it be caught by the person opposite? Will it be caught by the person to the thrower's left? Or by the person to the thrower's right?
Right, in your own time, throw the ball. I got this. Oh, whoa, whoa.
So the answer was D. It was caught by the person on the thrower's right. Our camera angles seem to show the ball bend in the air. So is that a camera effect, or are we seeing what they saw?
Hang on, this couldn't get much more simple. The idea was just to throw the ball straight to Victor to show us his amazing catching skills.
That's right.
Yeah, I did. It just curved right over this way.
So let me get this straight. So you threw the ball, it left your hands, and then what?
And then it just got sucked over to him.
In the air?
Yeah, I threw a perfect throw.
What did you see?
Yeah, curved right in.
Right, so we're all agreeing here the ball curved in midair.
Yeah.
Yes.
And you didn't cheat this at all?
No, I didn't.
Okay. And do you know why it did that?
No.
Nope.
No idea. It's called the Coriolis effect. And it's very simple. It's objects in motion it's an optical illusion, appearing to be deflected off their intended course. So what's actually happening here is you are throwing this ball. You can only throw a ball in a straight line. Can I clear that up straight away?
Yes.
Even though it appears in your eyes to be bending. So you throw the ball straight. It's still going straight, but the table is moving below you. And all of a sudden, look who's in front of that straight moving ball. And it looks like it's bent off to the right because you're still looking at the guy you were intending to throw it to. And that, ladies and gentlemen, is the Coriolis effect.
On its axis. And this spin has implications for the direction of the wind. We call this Coriolis. Now, you may have heard of the Coriolis effect or the Coriolis force. But this is not a real force. It's what we call an apparent force. It all depends on your point of view, whether you're looking down from above or, like most of us are, on the earth, looking from below upwards. Now, this is quite a complicated sounding business, but I've got a simple experiment to show it here. Chopping board, we've got a disc of paper pinned to that chopping board, a ruler and a pen. I'm also going to need a little bit of assistance, so Helen is joining me, and she's going to spin the disc of paper as if it was the Earth, as if we were looking down from the North Pole, from above the North Pole. That means you need to rotate that disc anti-clockwise. I'm going to draw a straight line along the ruler as Helen rotates that. And just look at what happens. The spin of the Earth means that that straight line is not straight. If you were looking from here, you'd see that the winds will be bending round to the right. That is Coriolis in action in the northern hemisphere. If it was the southern hemisphere, we were looking from below the South Pole, we would spin the disc the other way, clockwise. Try that at home, and you will see that the winds bend the other way, to the left. Now, you may have heard that Coriolis makes the water spin down plug holes in different directions in different hemispheres.
Sir, it is not an actual thing. It is an imaginary, a virtual effect, which is only existing because of the rotation of Earth. And practically, when we are talking about wind, it makes us feel that the wind direction is changing. So, the wind we experience is always a function of two forces: pressure gradient force, high pressure to low pressure. The pressure gradient force decides the speed of the wind. Larger the pressure gradient force, that is, the larger the difference between high and low pressure over shorter the distance, stronger the wind. That kind of thing. ये तो सीधा हो गया. But we experience wind direction. Forget about moving. You are at anchorage, wind direction changes. That is all because of the Coriolis effect. So the wind we experience is a resultant of pressure gradient force and the Coriolis force. So when we come to our, I will wait that just a small thing before we stop for this lecture. Earth is rotating from left to right, west to east So the feeling of the effect of Coriolis is it will deflect to right, meaning the wind direction, it is from here to here, it will deflect to right. Wind direction is from here to here, it will deflect to right. ये नहीं कि भाई सर यहाँ पे इस तरफ जा रहा है westerly तो यहाँ पे क्यों नहीं? नहीं, then that will be deflection to left. Northern hemisphere wind deflects to the right. High to low, it is moving from here to here, it gets deflected to the right, toward the left in the southern hemisphere.